Hello student, now today we are going to see the next topic, tangents plane from the unit number 5. So basically a plane which is tangential to the sphere is called as a tangent plane. Now all of you know the equation of the sphere is look like x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equal to 0. This is the general equation of the sphere. Now, if we have a tangent plane to this sphere at the point x1, y1, z1, suppose this is the point of contact of sphere and the plane. Then how to write down the equation of that tangent plane? This is the formula for it. So, the equation of the tangent plane is given as x1 plus y1 plus z1 plus u times x plus x1 plus v times y plus y1 plus w times z plus z1 plus d equal to 0. Basically, to remember this equation of the tangent plane, what you have to do is, see, if you look at the equation of the sphere, you can write down that x square as x into x. Similarly, y square you can write it as y into y, z square as z into z. Okay, and this 2ux you can write it as x plus x into u. Similarly, y plus y into v, z plus z into w. So one of the x, y and z you have to replace by that point x1, y1 and z1. So the equation will look like x1 plus y1 plus z1 plus u times x plus x1 plus v times y plus y1 plus w times z plus z1 plus d equal to 0. So easily with the help of equation of the sphere you can remember the equation of the tangent plane. Okay. Now one more thing, if you observe over here in a tangent plane, there is one more property of tangent plane you can easily see over here. This is the tangent plane and this is the sphere. So if you join this line from the center of the sphere to the tangent plane, this length is nothing but the radius of the sphere. Also we can say that this distance is nothing but the length of the perpendicular from the center of the sphere to the tangent plane. Okay, so whenever the length of the perpendicular from center of the sphere to the plane is equal to the radius, then we will say that that plane is a tangent plane, because when the plane is tangent plane, then only these two length will be same. Otherwise, if it is not a tangent plane, this length will not be equal. This is a very important property of a tangent plane. Whenever a plane is tangential to the sphere, the radius of the sphere is same as length of the perpendicular drawn from center of the sphere to the plane. Okay. Now let us see some examples on the tangent plane. So this is the first example. Find the equation of tangent planes at the point where the line x plus 3 upon 4 equal to y plus 4 upon 3 equal to z minus 8 upon minus 5 intersect the sphere x square plus y square plus z square plus 2x minus 10y equal to 23. Now what is given in this problem? So it is given that this is a line, okay, which intersect the sphere. Okay, now when if you look at the diagram, when the line intersect the sphere, this is the 2 points where we can draw the tangent to the sphere. Okay, so that two tangent planes equation we want to find out. Okay, now how to do it? Let's see. Now all of you know that the equation of the line is given as x upon 3, x plus 3 upon 4 and so on. What we are going to do? We are going to take it as t. So what we can do with the help of this, you can find out the coordinates of any point on that line. Okay, so let pxyz be the point of contact of the plane and the sphere. That means we are talking about these 2 points. This is the point of contact of a plane and a sphere. Okay, so one of this point, actually we don't know right now whether there are 2 planes or 1 plane. Okay, here we can visualize in the diagram, basically there will be 2. So but we are going to start with 1 point, pxyz be a point of contact. Now this point pxyz, how we are going to get x is equal to what? X is equal to 4 into t minus 3. Similarly y will be 3t minus 4 and z will be minus 5t plus 8. This will be the values of x, y, z. But this point is also lying in the sphere. That means this point that we are getting x, y, z will also satisfy the equation of the sphere. So when you put this value of x, y, z in the equation of the sphere, and when you simplify it, you are going to get t square minus 3t plus 2 is equal to 0. So that gives you there are two values of t as 1 and 2. Now when you put t is equal to 1, what you are going to get? X will be 1, y will be minus 1, and your z will be plus 3. So this will be the first point, and when you put t is equal to 2, you will get another point. So what is this 2 points? These 2 points are nothing but this one. These are the 2 points that we are having. So these are nothing but a point of contact. Okay, and as I told you, if once you have a point of contact, you can easily find out the equation of the tangent plane, because if you know that when your equation of sphere is given, and if you know the equation point of contact, you can easily write down the equation of the tangent plane. So we are having an equation of sphere over here, we are having a point of contact also. So simply you take this as x1, y1, z1 and put it in the equation of the sphere. You are going to get a two equation, one with 1 minus 1 3 and another with 5 2 minus 2. Okay, and these are the two equations of tangent plane you are going to get. I hope you are getting this thing, because quite a straightforward problem. Now we'll start with the second example. Find the equation of a tangent plane to the sphere x square plus y square plus z square plus 6x minus 2z plus 1 is equal to 0, which passes through the line 3 times 16 minus x plus is equal to 3z equal to 2y plus 30. Okay, so again we want to find out the equation of the tangent plane, and what is given to us, we are having one sphere which is passes through the line. Okay, that means we are having a sphere which passes through the line, this one. Okay, so if you look at the diagram of this one will look like actually like this. It's there. Okay, so we are having a sphere, and that sphere is passing through this line, and what is given to us in the problem, you are having the line equation. But listen, basically the line is nothing but what? It is the intersection of two planes. Okay, because whenever the two planes intersect, the intersection that you are going to get is nothing but a line. You can observe in this diagram here, if you look at this, these are the blue one and the orange one are the two planes, and if you look at the intersection, this is the line. Okay, even in the diagram also, in this diagram also you can observe this is one plane, this is another plane, and the intersection of that two is this thing but this line, and that sphere is passing through that line. Okay, this is given to us. Okay, now how we are going to find out the equation of that two planes? So simply we'll try to write down this, the equation of line that is given to us, we'll try to write down in terms of two planes. Okay, because as I told you, the intersection of two planes is nothing but the line. Okay, so when you simplify this, when you separate it, this part and this part, you are going to get a two equation, and that are the equation of two planes. Okay, now equation of any plane passing through the given line is given as u plus lambda v is equal to 0, where u equal to 0 is the equation of first plane that already we have mentioned. This is nothing but your u, and this is nothing but your v. Okay, so this is your two planes. So when you simplify it, it should be lambda here, lambda, not k. So you are going to get an equation like this. When you simplify this one, you are going to get x plus lambda 2 lambda k and so on. Simply instead of k it should be lambda. Okay, and we are having the equation of the sphere as this. Equation of sphere is this, and if you compare it with the general equation of the sphere, you can find out the value of u as 3, value of v as minus 1, and value of w as, there is v will be 0 because there is no y term, and w will be minus 1, and your d is 1. Okay, I hope you remember how to get it. You equate this to 6x with 2ux, 2vy and 2wz, and when you equate you will get the value of uvw. And I hope you remember the center is given as minus u minus v minus w, and the radius is under root u square plus v square plus w square minus d. So with the help of that two formulas you can find out the center and the radius of the sphere. The center will be minus 3 0 1 minus 3 0 comma 1, and r will be 3. Okay, now the required tangent plane, as I told you in the beginning, whenever the plane is tangential to the sphere, the length of the perpendicular from center of the sphere to the plane is same as the radius of the sphere. So that formula we are using, this is the radius, and here I am finding out the length of the perpendicular formula. So we are putting the perpendicular from this point. So this is nothing but this point we are going to put it in the equation of the plane. So what is my equation of plane? This is the equation of plane, and I am putting this point in that, in the length of the perpendicular formula. So from this you will get this equation, and you are going to get two values of k as 1 and half. Now when you put k is equal to 1, you are going to get one value, one equation of plane, and when you put k is equal to half, you are going to get another equation of plane. Okay, so these are the two planes that we are going to get over here. I hope you are getting the idea. Okay, so that's it for today. In the next lecture we are going to see section of a sphere by a tangent plane. Thank you.